This is the video lecture for AP Calc BC, and we're looking at Chapter 4, Numerical Approximations, and so we'll be looking at Riemann sums and trapezoidal. So in our textbook, this is actually Chapter 4, Objective 2, which is the Riemann sums piece, and then Objective 6, which is the trapezoidal. So it's covering kind of that 2 and 6 and a little bit of Objective 3 as well. So for here, so this is a definition of what we call the limit of a Riemann sum. So this is how we're defining our definite integral. So this is the definition of the definite integral. So we have to have a function that's defined from a to b. So our lower limit is a, upper limit is b. And then the value of the region bounded by the graph of the function and the x-axis and your vertical line, so your limits are from a to b. And then this is how it's defined. So this component right here is what we call our definite integral, right? So this is our definite integral. And then this over here is our limit of our Riemann sum. So this is the component that kind of helps explain, you know, why is it that when we evaluate this, we get an area under a curve. So if we kind of break this piece down, so I'm going to go ahead and just off to the side here. And I'm going to just draw any function, it doesn't matter, so I'll just do a wiggle function here. And we'll just shoot that off both directions, so this will be our f of x. And so if we go from A to B, so wherever we're looking, and then C sub I is just any x value in between A and B. So on the interval. So that subscript I is what we would say is our ith interval. So first interval, second interval, that sort of thing. So if I'm just going to randomly break this up into 3 sections, and I'm going to just say, I don't know, we'll call this one right here C sub I. So if I were to take a look at C sub I, so f of C sub I would be this value over here, right? So that would be my y value. And I were to multiply it by the delta x of that particular interval, whichever one I want to, I'm just going to randomly pick this one over here, so I'm going to call that delta x. So from here to here is our delta xi, meaning it's the width of that particular section I was looking at, and then I multiply it by f of c sub I, okay, so f of c sub I would be the height, then that would calculate this area here, right? So when I am looking at this, this is area of a rectangle because f of c sub I is my height and then delta x is my base. So that gives me the area of a rectangle. This notation right here tells me to add up or sum all of those areas, okay? And then this portion right here says to increase the number of rectangles, so the n meaning the number of rectangles or intervals, to infinity, right? So increase the number of intervals or rectangles to infinity. So right now, if I look from A to B, I have only 3 intervals, right, that I drew out. And so if I were to look at those 3 intervals, and I square them up and make them into rectangles, and I find the area of each of those rectangles, then that would give me an approximation of the interval bounded between the curve and the x-axis. Not a very good approximation, but not horrible either. And so if I increase the number of rectangles, what ends up happening is that those size of delta x and the heights, that discrepancy between the actual area and the rectangle area diminishes, right? So if I were to squeeze in a whole lot of rectangles, and so I'm not going to go all the way across, but if you can imagine, and I'm nowhere near infinity, but if I were to look at topping off those rectangles, then the gap here that I am losing, right, the area of that rectangle versus the area under the curve is small, right? And I'm nowhere near infinity. And so as I increase that, my approximation of that area using rectangles loses the approximate status and turns into an equal component because I'm smooshing in so many rectangles that I start taking a look at that delta x gets smaller and smaller, approaching 0, right? And that's another way they'll define that as well. Limit as delta x approaches 0 as well. Okay? All right, so that is why the definite integral, right? So f of x is our height, is our y value, and delta x, or dx approaching, or delta x approaching 0 is kind of going to that dx. So what we're doing here is we're really finding base times height, right? So we're finding base times height, so we have a rectangle, and then the summation symbol when we are using integral. So this component, these two pieces here, is what this turns into here, okay? All right, so that is just to give you kind of an overview of why is it that the definite integral gives us, you know, an area. Okay, so let's go ahead and take a look at our Riemann's. So whenever we talk about a Riemann sum approximation, so this is an important, like, you know, piece of information that you need to kind of hold on to. So whenever we talk about a Riemann approximation, we are talking about approximating with the shape of a rectangle. Okay, so it uses rectangles to approximate the curve, and that's what we need to remember. And so we have, there's a lot of them out there, but we only are accountable for the left, what we call left Riemann, right Riemann, and midpoint Riemann. And when I say left, right, and midpoint, that is just saying you are choosing what side of the interval to create the height. So if we talk about a left Riemann, we're using the left side of the interval to create the height. So specifically, let me draw a picture here. And then I'm just going to do kind of a half of a parabola. And so let's say we're going across this section right here from A to B. And let's say I only want to use 2 sections to approximate. So if I refer to a left interval, that means, or a left Riemann, sorry, on this first interval here, I use the left side to create the height of that shape. So I'm going to go to the left side and I'm going to draw straight across, and then this is the rectangle I will use to approximate the area under this curve. And I would do the same for the next section. So the next section I use so we have 2 sides to the interval. I use the left side, and then I use that rectangle to approximate the area under this curve. So that is a left Riemann, okay? So it uses the left side of the interval to create the height, sorry about my terrible handwriting, to the height of the rectangle. Okay, so it's like half cursive, half print there. All right, let's take a look at the right interval. So if we're talking, or right Riemann, sorry, I keep saying that. So the right Riemann, so again, I'm just going to do a half of a parabola there. We'll say that's B and that's A, and we'll go ahead and just do 2 sections. So I'm just randomly picking 2, right? They'll tell you what they want. Okay, so here's 2 sections. So if I want to draw a rectangle to approximate this curve, I have the left side and the right side of the interval. I'm using a right Riemann, so I would pick the right side and then draw my height accordingly. So here's my next interval. So again, if I do a right Riemann, so on this interval I have the left side and the right side, so I'm going to use the right side to create the height. And I'm going to find the area of that rectangle and approximate the area under the curve, right? So this one would be an over approximation, right? Because I have too much area that I'm using to approximate under the curve. This one would be called an under approximation because my areas are under, right, smaller than the actual. All right, and then finally on midpoint, so the midpoint approximation, so let's go ahead and draw that same picture. And I'm going to go from A to B again. Find a spot there. So I have 2 intervals again from A to B, so 1, 2, and I want to use the midpoint. So the midpoint, so I'm not using the left side or the right side, I'm going to the middle, so wherever that middle is, we'll call it right here. And I go up to hit my function, and I use that to create my rectangle. And so do the same thing over here. So A to B, wherever that middle is, so I go up the middle, and then I go till I hit the function, and that is what's going to create my height, right? In the middle of the interval is what's going to create my height. And then I will use those 2 areas of those 2 rectangles to approximate the actual area under the curve. Okay, so that is what we've got. All right, so let's go ahead and take a look at our first example here. So for this example, so I'm going to go ahead and graph this so we can look at what we have. So we're going from 1 to 4. So we don't need a lot of room for the actual work, so we'll just draw this out. And I have the function x squared plus 1. So plus 1, so vertical shift of up 1, and it's a quadratic. And then I'm going to kind of exaggerate that section out. So there is my x squared plus 1, and I want to go from 1 to 4. So from 1 out to 4, wherever that happens to be. And so there's 1, and then 4 is up here somewhere. Let me kind of extend that out. And so there's 4, right? And now, so that's my picture. So I'm looking for the area under the curve between 1 and 4. So I know how to do that, right? Find the exact value. But we're asked to do an approximation for it, and we're going to do left, right, and middle. So n is equaling to 3, so that means we need to have 3 sections between 1 and 4. So that would be at 2 and at 3. And so I'm just going to draw my vertical line until I hit my function. And so I have 1, 2, 3 intervals. So I want to do a left Riemann sum, right? Left Riemann sum. So I'm going to do that approximation. So I'm going to do from 1 to 4 of x squared plus 1. And I'm going to approximate with a left approximation. So if I look right here, I have my first interval. So I need to use this as my height, right? And the left side is my height, and the left side is my height, right? So what did I do? So I have left side, right side, and I went to the left and hit my function and drew across. Left and right, I chose the left, and then drew across. Left and right, I chose the left where it hits and went across. So I have these 3 rectangles that I need to find the area of. So I'm going to go ahead and write out my ordered pairs here just so that I have each of those. So I'm going to just do a t-table just to kind of work through it that way. So my function is x squared plus 1. So when x is 1, y would be 1 squared plus 1. When x is 2, that'd be 2 squared, which is 4, plus 1, which would be 5. When x is 3, 3 squared is 9, plus 1 would be 10, right? So my first rectangle has a base of 1 and a height of 2, right? Because that ordered pair is 1, 2, so that height would be 2. So base of 1, height of 2. And then I go to my next rectangle, also has a base of 1. And then its height is right here, so when x was 2, my y value was 5. And then over here, my third interval, third rectangle, base of 1 again. And then my height was when x was 3, my y was 10. And so that approximation would be 1 times 2 plus 1 times 5 plus 1 times 10. And then, of course, if I want to take the time to add that up, that would be, what, 17? And so that approximation would be 17. Okay? All right, and so now let's do a right Riemann. So it would be that interval again. So I'm just going to be about equal to that integral. So for my right Riemann, so I'm going to use red here to talk about that. So for my right Riemann, so I've got 3 intervals again. Left side, right side, but this time I'm going to use the right side to create my rectangle, right? So it's going to be an over approximation this time. So then again, I'm going to do the right side to create my next rectangle, and then I'm going to do the right side to create my next rectangle. So this time I have these 3 rectangles that I have to find the areas of because I use the right side of each interval to kind of cap it off, right? So for this first rectangle, they all have a base of 1. All right, so I'm going to not say that anymore. So base of 1, and then my height was from x equaling 2, so 2, that would be a height of 5. And then for my next rectangle, the 3 created the height, so when x was 3, y was 10. And then for the last one, it was created when x was 4, so 4 squared is 16, plus 1 more is 17. Right? And so then in this case, it would be 5 plus 10 plus 17, which is hopefully 32, right? Yeah. Okay. All right, so then now finally, so for midpoint, I've got to actually go into the middle, right? So that means I need to use 1.5, 2.5, and 3.5. So I would go up to 1.5, and I'm going to have to find that value, right? And then up to 2.5, find that value, and then up to 3.5, and then find that value, okay? My pen just kaputzed out on me. Okay, so then I'm going to have to find each of those values. So at x equals 1.5, 2.5, and 3.5, right? So I'm going to use my calculator for that, so I don't have to do that by hand. And so I'm going to have 1.5 squared and then plus 1. So that would be 3.25. And then I want to do the same thing at 2.5. So that would be 7.25. And then one more here at 3.5 would be 13.25. So I just use my calculator to do that by hand. All right, so here goes my midpoint. So again, this is another approximation. So I'm going to do my base, of course, is 1, and then the height at 1.5 is 3.25. And then my next interval, also a base of 1, and its height would be 7.25. And then finally for the last interval, the height at 3.5 was 13.25. And then I would add up all of those. So hopefully my arithmetic is good. Okay? And then, so that is how I would work it with that. And then of course I can, do this by hand, right? I know how to do that. Or use my calculator to kind of check my answers and see how they are. Okay? All right. So let's go ahead and go on to the last page here. Okay, so page 2. So this page 2 is more along the lines of the types of questions you would run across where they don't actually give you the function. They just give you data points, which is, like when you have like these real life situations, typically you don't have a function to work with. You have data points that you've collected out in the field. And so this would be more along the lines of what you would expect. Okay, all right, so here they're asking us to approximate the integral from 0 to 10 of r of t with a right Riemann sum, and then they want you to use 5 equal subintervals indicated by the data in the table below. Okay, so our 5 equal subintervals would be, we would be going from 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, right? So these are like our x values, and these are our y values. So we are going to integrate from 0 to 10 of r of t dt. So again, like these are our x values, right? And these are our y values. And we are doing a right Riemann sum. So I'm going to highlight that so I don't forget halfway through the problem. Okay, so right Riemann sum. Okay, so for this one right here, what I want to do is I want to take a look at the first interval going from 0 to 2. So right, this is my delta x. So I'm starting at x equals 0 or t equals 0 and going to t equals 2. So from 0 to 2, my delta x would be 2 units, right? 2 units across. And then I have 2 y values to pick from. I have a 12 to pick from and an 8 to pick from, right? So over 0 up 12, over 2 up 8. So which y value do I use for my height? The 12 or the 8? And I'm going to use the 8 because I'm doing a right Riemann. So then that would be 2 times 8, right? So my base delta x is 2. And then I have to pick a height, and I either am going to use 12 or 8, but I want to use 8 because it's at a right Riemann sum. And then now I'm going to go to the next interval, so from 2 to 4. So I'm going from 2 to 4. So that delta x from 2 to 4 is 2. And then now I need to pick, do I use 8 or do I use 4? So 8 is on the left side, 4 is on the right side of the interval. So 4 is what I want to use because I'm using a right Riemann sum. And then I go to the next interval, so from 4 to 6. Are you seeing a trend here? So from 4 to 6, that delta t would be 2, so my base is 2 units, and now I need to pick, do I use 4 or negative 2? And I have a right Riemann, so I'm going to use the negative 2. And then now we're going from 6 to 8. So from 6 to 8, how far is that? 2 units apart. And then now I need to pick my y value to create that height of that rectangle. Do I pick negative 2 or do I pick 0? It's not eeny meeny, people. If it says right Riemann, I'm going to pick the right side, so that would be 0. And then my last interval here, so 8 to 10. So when I go from 8 to 10, that's 2 units across. And then now I need to figure out, so there's my base, 2. Now I need to figure out what height do I use, 0 or 8. So is it eeny meeny? It is not eeny meeny. I use the right side. So that would be 8. And then you can leave your answer like that. You certainly don't need to simplify that. Like that would be like golden right there. But if you have that need, go ahead and do a little arithmetic for me. But this is usually when things might go wrong. So if you see a mistake, be sure to share. All right, so then this would give me 32, 40, 36, maybe 36, hopefully 36. Okay, and then the units here, let's go ahead and do that. So these were all feet per minute, and then I'm multiplying by minute, so then that would give me 36 feet, right? Okay, so if you feel good about it, try the next one on your own, okay? Otherwise, we'll go ahead and go over this together. Okay, so in this particular problem, we're doing a midpoint Riemann sum, and they tell us what intervals to use, 0 to 2, 2 to 4, 4 to 6. Okay, so we're going to do the same thing again. So we're going to integrate from 0 to 6 of f of x dx, and then I'm going to do in a midpoint Riemann sum. So we're going to go from 0 to 2, so from 0 to 2. And so how far across is 0 to 2? That would be 2 units. And then now I have 3 y values to pick from. I have a 7, a 3, and a 5. So do I use a 7, the 3, or the 5? Well, how I know is right here, ding, 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 midpoint. So 7, 3, 5. So midpoint, so there is my middle, right, at x equals 1, so my midpoint, so that would be a height of 3. And then let's go to the next interval, so from 2 to 4, so here is 2, and there's 4. So from 2 to 4, that delta x is 2. And then now I have a 5, a 1, and a 0 to pick for my height. Should I use the 5, which is on the left side? Should I use a 1, which is in the middle? Or should I use a 0, which is on the right? And I'm going to use the 1. And last one, so from 4 to 6, so 4 to 6, so also delta x of 2. And then now I have to pick. Should I use the 0, the 6, or the 2? And because it's a midpoint, I'm going to use the 1 in the middle, which is the 6. Okay? And then I'm not going to do the arithmetic on that. But there you go. All right, and then here is our last concept. So our last approximation that we are responsible for is trapezoidal. So trapezoidal approximation of area is still kind of utilizing that same idea, but we use trapezoids to approximate as opposed to rectangles. So if you've forgotten the area of a trapezoid formula, so there it is. It's in a trapezoid like geometry format, we would say it's the average of the bases. Excuse me. The average of the bases times the height. But we are actually working with function, or a function. So we are going to talk about it just a little bit different, use different formulas. So if I want a trapezoid, we use what we call a right trapezoid. So we'll have this side right here. So these will be my parallel sides. So this is typically, the distance here would be what I would call my height. And then connect, right? So that's what we're doing as a trapezoid. Okay, so that is our trapezoid that we're working with. So typically when we saw trapezoids, they looked something like this, right? Or if we had a right trapezoid, it looks something like that. So it's this guy right here, just flipped up 90 degrees, and that's what we're referring to. And so when we say the average of our bases, these were what we called our bases in geometry, okay, which are our heights. So the way we're going to actually think about it is we average our height. So I'm going to do F1, let me just do F of A. So this would be F of A, right? So the height would be F of A, and then plus F of B, right? Or like, don't think A and B mean my endpoints, like upper limit, lower limit. I'm probably not using the most appropriate letters because that might translate into, you know, like we just use the ends, but of the interval, right? So F of A to F of B. So we average those values, and then our height is actually right here, which is our B minus A, or our delta X. Okay? So it's the average of the Y values, right? And then times delta X. Okay, so that's the way we want to think about it. So the average of the Y values, and then times delta X. Okay? Okay, so that's like kind of the big ticket item right there. Okay, all right, so again, because our y values are really the bases, or what we would call our base, the parallel sides, and then the height, the delta x, is the distance between the parallel sides. Okay, so let's go ahead and do this example. So it says to approximate the integral from 0 to 14, and they want you to use 5 subintervals. So we are going to do that. Okay, so we have to know delta x, and then we average the height. So trapezoids, okay, so we're going from 0 to 2, 0 to 2, so that delta x is 2. So I have two y values here, right? So if it was a left Riemann, I'd multiply by 5. A right Riemann, I'd multiply by 10. Midpoint, I wouldn't be able to do because I don't know what it is at 1. For trapezoid, we add and divide by 2. So I'm going to do 5 plus 10, divide by 2. So we average. And now I'm going to move on to the next one. So from 2 to 5, right? So 2 to 5, so that delta x is 3. And then I have two y values here. And because I'm doing trapezoidal, I average the y values. And then let's go into the next section. So 5 to 6, that would be 1. And then I average the y values. And then now we go to the next set. So from 6 to 10, that's a distance of 4. And then I average the y values. And then our last section, so from 10 to 14, that would be a distance of 4. So I'm going to do that below. And then I average the y values. Okay. All right, and then I am going to go ahead and do the arithmetic just because I have a part B here. So those 2's cancel, so then 5 plus 10 is 15. And then I have 3 times 22 divided by 2. And then I have 14 divided by 2. 8 divided by 2 is 4 times 4 is 16. And then finally, reduce that. So what is that, 18? And then I'm going to do that arithmetic. I could totally do this in my head, but I'm going to use a calculator right now and hope I did not already make a silly little mistake. Okay, so I'm getting 89. Okay. All right, I just did a quick check and make sure I didn't mess up on at least from here to here. Who knows from above. All right, so then finally average value. So our average value, so typically we use f of c to represent that, is going to be the integral from 0 to 14 of r of t dt, all divided by 14 minus 0. And so we got 89 for that particular value. So that would be 89 divided by 14. And that would be my average value. All right, there you go.